Hello everyone, and welcome back to the next episode of Dana's Learning Lab. Today we'll be going over aromaticity and how to tell if molecules are aromatic, non-aromatic, or anti-aromatic. So I'm trying out a bit of a different format today, so let me know if you like this or not, and I can continue doing that if this aids in your learning more than in-person videos. So first of all, we need to go over Huckel's rules for aromaticity. This is the only way we can know if molecules are aromatic or not. Number one is that all atoms in the ring must be sp2 hybridized. This means that the ring is connected to three things. Now, by three things, one of those things can either be a lone pair, another atom, or a bond, including single bonds, double bonds, and triple bonds all count as one thing. Number two, the ring must have n equal an integer using this formula. 4n plus 2 equals the pi number of electrons. That being, the pi number of electrons would be a bond. So each double bond counts as, 2 pi electrons, and then a lone pair is 2 pi electrons. So any lone pair or bond outside of the ring does not count, and a lone pair on a heteroatom will only count if it does resonance with the ring to be sp2 hybridized, which I will show you an example later on. And the third rule is that the ring must be flat. Now, by the ring being flat, there are some rules that also go along with this, which I have kind of made a chart for. So first of all, you have to know so these are the rules for it being flat. So are all atoms sp2? You have to ask that. So if yes, then you have to look at if the ring is 6-membered or less. So if the ring is 6 members or less, I apologize, I don't know why the keyboard keeps coming up. I'll have to toggle that. If yes, then it is flat. If no, then you have to look for sterics. Before I go there, if these are not all sp2 hybridized, then the ring is not flat. So if there are sterics, then it's not flat. It's not going to be flat. And this comes when usually you have fused rings. So that can cause sterics. But if no, then you have to consider if n is an integer. If yes, then it's flat. If not, then it's not flat, and that rule will not be satisfied. Rule 3. So this may seem a bit confusing, but overall, what to focus on is if it's 6-membered or less. Usually it is, for the less complicated cases, it will usually be 6 members or less, so you can automatically assume it's flat. And usually you'll only see if it's like a fused ring or something that you may have a problem there. So when you're going through an example for aromaticity, you have to consider the 3 Huckel's rules. So sp2 hybridized, n is an integer, and if it's flat. Anything outside of the ring does not count. If it's like a doubly bound oxygen or anything, you don't count that. So we will look at a few examples. I also want to go over the definitions for aromaticity and how they apply to these rules. So, if a ring is aromatic, it must satisfy all 3 rules. If it is non-aromatic, that means rules 1 and or 2 aren't satisfied. So if the ring is not sp2 hybridized, or if n is not an integer, then it is non-aromatic. It is anti-aromatic if rules 1 and 3 are satisfied, but rule 2 is not. Now we will go over a few examples of aromaticity and try to determine if these molecules are aromatic, anti-aromatic, or non-aromatic. First, I'm going to look at this molecule, A, and I notice that these carbons right here have 2 hydrogens attached. So I will draw those in just in case. Our first, also, this nitrogen has a lone pair. This one does, and this one too. Each one has 5 electrons. So our first question to ask is, are all atoms sp2 hybridized? So as I look at this carbon, I notice that it is connected to 1, 2, 3, 4 things, so that is sp3. Now we cannot change that with resonance, and that is the same for this carbon. So our first question is already no. That means since rule 1 is not satisfied, this molecule is non-aromatic. We don't have to go over the other rules because since rule 1 is already not satisfied, the rest will not be either. Going on to example B, I'm going to put in the lone pairs on the nitrogen. The same question, are all sp2? Well, first I'll look at this one. This carbon is connected to a double bond. Another carbon, and one hydrogen. So, therefore, connected to three things is sp2 hybridized. The same goes for this carbon and this carbon. Anytime a carbon is connected to a double bond, usually that will be sp2 hybridized. Now this nitrogen is also connected to a double bond, a carbon, and a lone pair, so that is also sp2. Our answer to this is yes. So we will go on to our next question, which is 4n plus 2 equals the number of pi electrons. So here, 4n plus 2 equals, I will highlight the pi electrons here. There's a double bond that has 2 pi electrons and another double bond that has 2 pi electrons. So 4n plus 2 equals 4. 4n equals 2 and n equals 0.5. Therefore, n does not equal an integer, and rule 2 is not satisfied. Although rule 2 isn't satisfied, but since rule 1 is, the third rule, which if it's flat, might be satisfied. We'll move this down. So, is it flat? Well, it is a 4-membered ring, so less than 6 members, yes. The ring is flat. So, since rule 1 and 3 are satisfied, but rule 2 is not, this molecule will be anti-aromatic. Now for our last example, we'll ask the same question, are they all sp2? The oxygen has 2 lone pairs, the nitrogen has 1. So this carbon is sp2, connected to 3 things, and you can add in those hydrogens if it helps. So is this one, and the nitrogen. Now, when we look at the oxygen, it looks like it is connected to 4 things. 1, 2, 3, and 4. But in this case, we can do resonance with the ring. So right now it looks sp3 hybridized, but when we do resonance with the lone pairs, we can move this one here and move this bond as a lone pair. So therefore, it will look like this. With a double bond and a lone pair. Therefore, the carbon will be negatively charged. And now the oxygen only has 1 lone pair, is connected to 1, 2, three things and is sp2 hybridized. So sometimes it can be tricky. If you can do resonance with the ring, then the atom will be sp2 hybridized even though it doesn't look like it from the start. So our answer to this question is yes. Our next question is, for n plus 2 equals the number of pi electrons, which I will highlight here. Oops. 2 and 2. And that may seem like it's all, but since this lone pair right here did resonance with the ring, we will count that one lone pair as pi electrons, but not the other one, just the one that did resonance. So 4n plus 2 equals 6. For n equals 4, n equals 1. So n is an integer. That rule is satisfied. The third question is the ring flat? And the answer is yes, because this is a 5-membered ring. Since all three rules are satisfied, this molecule is aromatic. So that's all I have for today's video. Thank you so much for watching, and I hope this helped. If you would like me to do any more examples or other topics that you would like to see, please let me know in the comments below. And I will see you all next time. Bye-bye.